So in the previous class, we had completed discussing about the infiltration, which means that was the end of the second module. Now we'll move on to the third module. So third module basically deals about how to understand the runoff, how to understand the stream flow, and also what are the methods in which we could be able to quantify the runoff that is coming from the catchment area. And there is one of the most important aspect of understanding the runoff using graphical solution, that is hydrograph. We'll try to understand that in this module. Okay, so let us begin with the third module. In the third module, as I already told you, that we are going to discuss about runoff. I had also explained the runoff when I was discussing about the abstractions of rainfall. So as a civil engineering point of view, what we need to understand is that there is a rainfall that is going to happen, and because of that a runoff will generate it. Okay, as we know, rainfall is basically the form in which the water reaches the earth's surface. Okay, and that water flows on the surface of the earth, and it flows beneath the surface of the earth also. And we need to understand what is the quantity of water that can be utilized by human being, right? That is what our perspective to understand the hydrology of hydrological cycle. So we basically want to understand how much is the rain water that reaches the earth's surface, and how much of that water is retained or stored on the surface and beneath the surface for the utilization of human being, right? So we already know what is hydrological cycle, what are the different components of hydrological cycle. The hydrological components can be divided into two forms. One is transportation components, the other is storage components. We have discussed all of this. Okay, so with respect to the point of view of civil engineer, we are interested to find out how much is the water that is coming to our streams, how much is the water that is flowing in our streams. That is what we need to identify, right? So while explaining you in the second module the abstractions of runoff, I had rainfall, I had given you this example also, that as a civil engineer we are interested to know how much is the water that is flowing in the stream, so that we could be able to store that water. So when the water reaches the earth's surface, it flows on the surface and it reaches the stream or a river, right? So when water is taking this travel from the basin area to the stream line or towards the river line, there are several abstractions that takes place. Abstraction in the sense, the water will not reach that stream. Whatever the water that reaches the earth's surface may not reach the river, right? What are those abstractions we had discussed about? The abstractions were infiltration, we had discussed about evapotranspiration, evaporations. These are the major abstractions that take place in the rainfall. Okay, and when rainfall is deducted by all these abstractions, that is the quantity of water that reaches our stream or river, right, or our natural channels. So that is what we are supposed to discuss in this entire module, in the third module. Okay, let us again quickly go look into this figure. In this figure, as you can see, the rainfall reaches the earth's surface, then there is some amount of water that is escaping in the form of transpiration, there is some amount of water that is escaping in the form of evaporation and transpiration, and then there is a water that is flowing on the top of the surface. Okay, after that the water gets infiltrated, and the infiltrated water may reach the groundwater table, or it may remain in the subsurface also, right? So the water that is flowing within the subsurface is called as interflow. Okay, and then the water that is infiltrated and which reaches the base, which reaches the groundwater, may also contribute to the river itself, which is called as base flow. So runoff combines of all of this. Runoff combines of overland flow representing the water that is flowing on the top of the soil, and then interflow, the water that is flowing in the subsurface, that is immediately beneath the surface of the ground. Then there is a base flow. Base flow is the flow that is coming from the groundwater table. Okay, wherever stream and groundwater table interact, whenever they meet, there either the stream or the river can contribute to the groundwater, or the groundwater can contribute to the river. So this basically can be calculated based on the hydrostatic conditions of that particular channel section. You can determine it. Okay, so I can explain you like this. If this line, this dotted line, is representing the level of water in the groundwater, and this free surface is representing the level of water in the channel. If the level of the water in the channel is at lower elevation and the level of water in the groundwater is at higher elevation, then there is the difference in the hydrostatic pressure created. The pressure difference is there. Because of that, the water flows from higher pressure to the lower pressure. It means what? The water flows from groundwater to the stream flow. If this condition was in the opposite, or in the reverse condition, where the level of water in the stream is at higher elevation and the level of groundwater is at lower elevation, there the water will flow from stream to groundwater. Okay, both can be possible. So base flow can be of positive in nature, or it may be negative in nature. Let me explain what is positive and negative with my perspective. Positive is that base flow which contributes from groundwater to the river. Negative is that flow in which the river is supplying water to the groundwater, right? So this is what we need to understand. Okay, so I had explained you in physical terms, or are trying to make you understand how the nature behaves with all these flows. Next, what we'll do is we'll try to understand the same thing over here, which are represented in terms of definition, of course. So there are surface runoff, overland flow, subsurface flow, which are interflow, and groundwater flow. The water that flows on the top is called as surface runoff. The water that flows beneath the earth surface is called as subsurface flow. Subsurface flow can be of two types. One is interflow and the other one is base flow. I have already explained you with that sketch what could be the overland flow, what could be the interflow, and what could be the base flow. Okay, so this is what a runoff is, and let us now try to understand with this flow diagram how basically the water reaches to the stream. Okay, now we all know that there is a precipitation that is taking place. Okay, then when the precipitation comes, the water reaches the earth surface and some of the water gets back to evaporation. Okay, now there is some amount of water that is going to contribute to the overland flow, the water that is flowing on the top surface. Okay, next is the water that is intercepted, or it has been stored in depressions, tanks, and all of those. So that is again the water which is getting evaporated. The water that is stored in reservoir, the water that is stored in pond, tanks, and all of those, the water from there gets evaporated. So that is also and again an abstraction that takes place. Okay, then simultaneously there is an infiltration that is taking place. So infiltration basically depends upon the saturation of the soil. If the soil voids are completely filled with the water, it gets saturated. By that time the infiltration will get ceased, or it will become uniform. Infiltration may get uniform, right? So whatever the water that is getting infiltrated is going to contribute to the unsaturated zone, and once this completely gets saturated, or meantime when it is getting saturated, there is the flow that takes place beneath the surface also. Okay, now the water that is just beneath the surface and the water that is flowing just beneath the surface is called interflow. After that, the water may also penetrate deep into the aquifers or into the groundwater zones, which is called percolation. So you need to make this distinction, what is infiltration and what is percolation. Infiltration basically explains you the water that is infiltrating into the soil. Okay, but percolation is that where the water which is available in the soil is getting it is getting entering into the groundwater table or in the groundwater zones. Okay, this is called as percolation. And then the water can further go beneath the groundwater also, which is called as deep percolation, which cannot be utilized by human beings. If the water is going to contribute to the groundwater table, like human has made sufficient mechanical instruments which can help you extract the water from the groundwater. Okay, but even your mechanical instruments has got some limitations, right? So you find any bore drilling well machines, they have their limitations. They can go for some prescribed or permissible levels of digging. They can't go beyond that. So the water can even percolate beneath the ground water zone, which is called as deep percolation, which is not mentioned over here. Here it is not mentioned. Okay, so first there will be infiltration, then there will be a percolation. Infiltration defined by a soil which is getting in, which is defined as a water that is getting infiltrated into the soil, and percolation is the water that is going deep into the groundwater, and if the water percolates even below the groundwater table, is called as deep percolation, where the water becomes fossil in nature. It becomes not accessible by human beings. Okay, now when the water is within the unsaturated zone, the water can be consumed by evapotranspiration necessities, right? The water can be utilized by vegetation, it can be used by agricultural area and all of this. So again the abstraction will take place from the unsaturated zone. Once the water reaches to the groundwater, as you can see, there is no abstraction from the groundwater zone, because the water in the groundwater aquifers are well below the earth's surface, where you cannot be able to extract from there naturally. There is no abstraction when water reaches to the groundwater table. Okay, there is only one mean, that is if the water that is available in the groundwater comes to the streamline, okay, or comes to the stream flow, okay, as a mode of base flow. Means I have explained you earlier in the figure that how there is a difference in hydrostatic pressures gets created. Because of that, the water may come from groundwater to the river, or river to the groundwater. So in that case, the water that is stored in the groundwater may come out into the surface. Okay, so this is how the stream flow is stream flows are generated. Stream flows are generated from the overland flow, interflow and base flow. This distinction we need to understand. Okay, so this we'll discuss about what is direct runoff and what is subsurface runoff. Subsurface runoff basically explains you the amount of water that is coming from the ground, and direct runoff is representing the amount of water that immediately comes to the stream. Okay, so, there is a time for both kind of water to reach the stream flow. Base flow will not immediately reach to the river. Okay, but direct runoff reaches like well after the rainfall period itself. Okay, so immediately after the rainfall period, you might see that there is an increase in the river water depth. Okay, whatever the depth that you see in the rivers may suddenly increase because of the rainfall that has happened a week back or 2 weeks back. This basically happens because all the water that is poured on the surface is getting converted into direct runoff, and the water is reaching to the streams. That's why there is an increase in the discharge in the stream. But you can understand the base flow or subsurface flow by a situation where there is no rainfall at all, but still the water is flowing in the stream. This basically happens because there is amount of water that was stored in the groundwater, and the water that was infiltrated and percolated into the groundwater zone are now contributing to the river, right? So subsurface flow or the base flow is something which comes at a long period after the rainfall, but direct runoff is one which immediately emerges after the rainfall. Okay, so this is what this table tries to explain you. Again, from the stream flow there can be evaporation. That is what being represented over here. Okay, this figures this flowchart basically gives you an idea of how all these components, all these various components of hydrological cycle are interrelated with each other, and how they are either expressing one particular identity, right? One particular component. Okay, so this is what a flow chart of stream flow. Next, what we will go do is we'll try to understand what is catchment area. Okay, I had given you an example of catchment area earlier also. In previous semester we had discussed about what catchment area basically means. So here catchment area is defined by a ridge line. Ridge line, you know what is ridge and valley lines. A ridge line is a line which separates a land naturally. Okay, so you can see in this figure, these are the streams that we have. These are the stream order of second, third, and all of those. So the water that that comes to the earth surface, if it is coming within this boundary, all that water will reach to this stream itself. This is what I call it as sink point. Okay, this is the point which we can call it as sink. Okay, so this is your source area. Whatever the water that precipitates in this area, that water will come through these through gravity in these small streams, and these small streams will further send water into these main streams through gravity itself, and then these greater streams will create a river. Okay, so whatever the huge river that you see outside are basically being contributed by small streams which might be even near your home also. Okay, so all those small streams are going to contribute to the larger stream and create the huge discharge into those river channels. Okay, now based on the shape of this catchment area, the runoff will vary, the discharge will vary. Okay, you can see this, these are some of the shapes which have been represented, and these shapes are going to influence the kind of hydrograph that will get generated. So let me explain you what is hydrograph. Okay, so you can see in this figure there is a special like description for hydrograph. We can go back to that later, but in brief I would like to explain you what this chart is representing you. So in this chart is, as you can see, that if there is a rainfall that has happened few weeks back or few days back, what happens is the water that comes in the form of direct runoff, the water that is flowing on the top surface, will reach to the small streams, and that those small streams will carry water into the larger streams, and then it will carry it to the river. So at this point, at the sink point, what you do is that you measure the runoff. You can basically measure the stream flow by various mechanical instruments are there to measure the discharge that is going from a particular channel section. So what we do is that we know the continuity equation, which is Q is equals to A into V. A is representing the cross sectional area and V is representing the velocity. Using this continuity equation, we can measure how much is the discharge in the stream, in the river at any particular cross section. So you can note down all the observations. So you will find that for whenever there is a rainfall that happens, because of that the discharge in the stream will increase. Okay, and as we know that rainfall will happen for a small duration. After that rainfall has been ceased, what happens, this discharge will keeps on reducing. So whenever there was rainfall, there you could see that the discharge in the river stream has been increased. Okay, after some time after the rainfall, you will see that there is an increase in the discharge, and it will reach to a peak. After that peak, again the discharge will keep on reducing, and it will become normal discharge, whatever the normal discharge was there. So what an engineer or a hydrologist try to interpret from this is that when there was no rainfall, whatever the flow that you can see is called as base flow. Base flow is basically the water that was contributing from groundwater to the river. Okay, so whenever you see there is an increase in the discharge, you can see that there is somewhere rainfall has happened. Because of that rainfall, direct runoff has been created. Because of that direct runoff, it has contributed to the increase in the discharge of the stream. Okay, so this graph is called as hydrograph. Okay, we'll discuss this graph later also. Okay, as you can see in this figure, different shape of catchments will create different type of hydrographs. Okay, now you can see over here the steepness of the profile. Steepness means what if whatever the catchment area is there, if it is completely mountainous area, it is mountainous terrain where the slope is really high, it means what, the time taken for water to reach from the place of where it falls to the stream will become less because of the increase in the gravitational force. Steeper the areas, like it will take a small time for water to reach to the place of precipitation to the place of discharge, right? So water easily travels from the place of precipitation to the place of stream, right? This is what you need to understand here. So if your entire catchment area is steeper, then you can see the time taken to create a peak discharge is very small. If the entire area is of like a gentle slope, in that case your peak will not be that high, and the discharge will be distributed for a long period. Okay, so steepness of the slope of the area either will create a greater peak for a smaller discharge, for smaller rainfall, or it may even create a very small peak for even the smaller discharge. Okay, so this is what you need to physically try to interpret how and what will happen based on the catchment area. Okay, now going to the drainage density, you can see that higher the drainage density, you can see that the duration of creating a peak is very high. Okay, but in case of lesser drainage density, you can see that this curve is. The next thing is, let us try to understand the factors that are affecting the runoff. There are the factors can be classified into two different criterias. One is on climatic factors, the other one is physiographic factors. So whatever I had explained you with respect to the catchment area, the response of rainfall and runoff by the variabilities in the catchment area can be categorized in the physiographic factors. Okay, and whatever I explained earlier with respect to the rainfall conditions, we can categorize them in the climatic factors. Okay, let us look into climatic factors first, and then we can go for physiographic factors. So this is your climatic factor based on the type of precipitation, like if it is cyclonic precipitation, frontal precipitation, or any other orographic precipitation, or any other precipitation, that will basically influence you the kind of runoff that will generate it, right? So you know what a cyclone can create. Okay, then you know what is frontal precipitation is the nature of how the rainfall will happen, what will be the pattern of that. So based on that, you can define that is one of the factor in influencing the runoff. Okay, next is the intensity of rainfall. Okay, if the intensity is higher, the direct runoff will be more and subsurface runoff will be low, and the base flow will get reduced. Okay, so if the intensity is less, duration is greater, the water will get infiltrated and less direct runoff will be there, and because of that the runoff will be also less. Okay, right. Next is a duration of rainfall. If the precipitation is taking for a longer duration, then you can see that the runoff will either increase at a greater extent. If the duration is very small, there may not be even runoff, direct runoff may not even get created because of shorter duration. Okay, now area distribution of rainfall. Every rainfall will have its own area in which it gets precipitated. The areal extent depends on the type of precipitation we have, right? So based on the cloud density, this area in which the rainfall is going to happen is decided, or it basically happens in that manner. So we may not be able to judge what could be the area of rainfall. We do not have that amount of sophisticated technologies developed, though in the foreign countries they can actually predict how much is the rainfall that is going to happen. That is what we call it as weather forecasting. Weather forecasting is basically a way in which we could be able to quantify the amount of rainfall that may happen in the coming days. Okay, based on the cloud, we try to understand what is the total clouds that are flowing around any given area. Then we try to determine, or we try to judge, what if this rainfall or what if this cloud that is formed will precipitate onto the immediate ground beneath it. Okay, so these are some of the ways in which the forecasting will take place. So that is what areal distribution of rainfall is. So aerial distribution of rainfall basically means that what is the area on which the rainfall or the precipitation has happened. Okay, now coming to antecedent or previous precipitation. Antecedent means in the term itself it has been explained, the precipitation that has happened previously. So imagine a day before there was a huge rainfall, and today again there is a rainfall. So the runoff that you see in the stream or in the river is not the runoff coming from this day, today's rainfall. Okay, it is also contributed from the previous rainfall. Okay, while explaining you the infiltration also, I explained you that if infiltration rate basically depends upon the infiltration that has happened previous day. Okay, if there is a rainfall that has happened in the previous day, because of that itself the soil or the earth would have been completely saturated. Okay, so whatever the precipitation that takes place today may get converted into direct runoff, right? So it is important for us to identify for any given runoff, it is important for us to identify what is the antecedent rainfall or previous rainfall, previous precipitation. Other climatic factors that affect our evaporation, transpiration, and all of those things, as we know that they are the abstractions, they do have the influence on the runoff. Next, going to physiographic factors. The first term is land use. What is the purpose of the land being used? What is the type of soil we have? Type of soil basically plays an important role in the accumulation or the storage of water. Okay, I told you that there are several storage zones. Soil is also a part of storage zone itself, because the soil holds water within its voids, and soil being one of the largest storage of water. Okay, other than the groundwater and surface storage. So type of soil will decide what is the amount of water that can be stored in the soil, and how much of the water that gets penetrated into the groundwater, and how much of the water will flow on the earth surface. Okay, these are some of the area, and I have also explained you what is area of the basin or catchment area. Based on the area of basin and the catchment area, the runoff will take place. Shape of the basin, I already explained it. Elevation, slope, they are also being explained. Next, type of drainage networks, in the previous slide itself I explained it. So these are some of the physiographic factors, and we have climatic factors. So these are the factors that are influencing or that are contributing to the runoff. Okay, right. Let us now try to understand what is hydrographies. Okay, so in the picture it is very much clear to you that there is a line, blue line. This blue line is representing the discharge in the river. Okay, I explained you while explaining the runoff how do we measure the stream flow. Okay, so what we do is that we'll consider a cross section, a very stable cross section whose cross section must not be changed. Engineers must identify that kind of cross section where its section will not change over a period of time. Okay, you may get confused with this, but let us try to understand the natural streams. What happens is that if you have visited to any river, there are some channels which do not change its cross section, but there are channels which frequently change its cross section. The best example I could give you is that when you go towards Bagalkot Road, there you come across a bridge called as a Don Bridge. Okay, if you have traveled for over a year, you might have seen how the cross section of the stream changes. Okay, so it was pretty difficult for engineers to provide a suitable bridge over there because the cross section was constantly varying. The streamline would change its course over years. Okay, so that's why it becomes very unpredictable for engineers to even construct that bridge. Okay, I don't know how many of you know that location, but I want you to I can't just explain you the exact location over here because I don't know exactly what that river was called. It is Don River, Don Bridge, and just to give you a physical explanation for it, if you go towards Bagalkot Road, in the direction of Bagalkot, I don't remember what is that village name. Okay, anyhow, so there is a railway gate. After the railway gate, you will find there is a small village. After that village, you will come across two bridges. One road bridge is there, the other one is bridge for train. Okay, so that is the area I'm speaking about, and that cross section varies yearly. I could say even yearly it changes. So in such kind of unpredictable cross sections, you cannot install a stream gauging station. Stream gauging station has to be established on a channel section where it is stable, whose course will not change. Okay, so let us try to understand what is the importance of not changing the cross section. If every year the cross section changes, it becomes unpredictable for us to, it nearly becomes unpredictable to measure the discharge, right? So we want our cross section to remain same. As we know, our continuity equation Q is equals to A into V. V can vary, velocity can vary, but cross section should not vary. Cross section should remain same, right? So that from that we will calculate how much is discharge. So if the cross section remains same, then only we can compare the discharge values of different time. If the cross section keeps on changing, we cannot measure, we cannot vouch for the discharge that we are calculating. Anyhow, that's how it is. So you need to find a cross section where the channel section will remain stable, and there you need to measure the velocity, and you already know the cross section, so multiply with that, you will get the discharge from the stream. Okay, so what this hydrography has been done is, on the x-axis there is a time, okay, which may be in terms of hours, which may be in terms of days or anything. Okay, so on y-axis scale, okay, on the ordinate side we will have discharge. Okay, so discharge by time, the graph is drawn. Okay, so discharge is represented in terms of meter cube per second, which you all know, and let us try to assume that it is done after every 4 hours or something. If after every 4 hours the rain discharge has been recorded, right? So your interval will become 4 hours. So every 4 hours you measure the discharge and you draw the ordinates over here. Okay, if you connect it by a curve, this curve will be called as hydrograph. So hydrograph is representing the variation of discharge with respect to time. Okay, now why is this called as hydrograph, and what is the importance of hydrograph, we will try to understand. Okay, so you can see that this is being represented by some pale green. This symbol is representing you the hydrograph. So hydrograph is representing the rainfall. If there is some amount of rainfall that has taken place for any given region, what you do is that you calculate the intensities and you draw the bars like this. So these bars are representing the rainfall. Okay, so because of this rainfall, there is no immediately rise in the discharge. As you can see, this is normal. In the river there is no change. Okay, but once the rainfall has been ceased, you can see that the discharge in the river is increasing. So you need to understand what is this condition. Whenever there is a rainfall that happens, all the rainfall is not directly going to fall on the stream itself. What it does is that it falls away from the stream. Okay, then through the gravity the water will flow towards the stream and it reaches the stream, right? So because of that, if this is the duration of rainfall, after the rainfall has been ceased, you can see that the discharge in the river is increasing. Okay, then it reaches some peak point. Whatever the water that is converted as a direct runoff will contribute to the stream directly, and because of that there is a rise in the discharge, and after that it ceases, it gets reduced. Okay, so it gets reduced and then it falls. Okay, so this is called as a rising limb. Rising limb is basically the increase in the discharge in the channel because of the rainfall that has happened previously, and after that it reaches the peak discharge or the maximum discharge in the channel. Okay, in which you can see that the entire channel is flowing full. Okay, so in that case the peak discharge is created. So after that peak discharge, the discharge keeps on reducing and afterwards it will become stable. Okay, you can see that this line this portion, which is represented by a little dark blue, this area is representing you the base flow. Okay, so whatever the rainfall that you see over here between this portion, it is because of the direct runoff. Okay, and whatever the water you see beneath this, this is called as base flow, or it may be because of the antecedent rainfall. Antecedent rainfall is the rainfall which has happened previously. Okay, so the influence of discharge in the river only because of this river can be remarked by this area. Okay, so in this we are again divided into two parts. This part is representing the water that is flowing on the surface. This is the part which is flowing just beneath the surface, which is called subsurface flow. Okay, so like this hydrograph gives you an explanation of what is base flow, what is through flow, and what is storm runoff or direct runoff. Direct runoff is the runoff which is flowing on the top surface of the soil. Okay, so that is what hydrograph is. So this is how we understand the runoff in any given stream or a catchment area. So if you have any doubt regarding this, you can ask the question. In future, what we'll do is we'll start understanding the hydrograph by solving the problems. I just want to solve problem and explain you the unit hydrograph and all the other components. Okay, so I have already sent you the notes, so you can refer the notes and study this hydrograph also. Okay, thank you.